Let me introduce our prominent resource person on today's first session, Dr. B. Surendiran, Associate Professor, Department of Computer Science and Engineering, National Institute of Technology, Korekal, in the topic of dimensionality reduction for medical imaging. He has received his PhD from NIT Tiruchirappalli in the year of 2012. He has delivered more than 85 guest lectures and reviewed more than 600 research papers as on date, and he published more than 55 research papers to his credit. He received Top Reviewer Award from publications in the year of 2019. I welcome you, sir. Without any further
Thank you.
delay, we would like to start the session. Thank you very much for joining this session, sir. And we would be delighted to have the participant suggestions and questions at the end of the presentation. Thank you very much.
Okay, madam, I'm sharing my screen.
Yes, sir. Over to you, sir.
Yeah. Is it visible, madam?
Yeah, yes, sir. It is
Okay.
visible.
Yeah, thank you, madam. Very good morning to everyone. So myself Surendiran from NIT Puducherry. So today we'll be discussing about dimension reduction methods. So why dimension reduction methods and what are the usages I'll be discussing today. What are the various dimension reduction methods, and I will show demonstration also. So today's content, it's about why dimension reduction and what are the various methods like filter, wrapper methods and all those things. I'll be discussing that. And demonstration using iris dataset in Vika tool. And I'll also talk about SVB ratio and the work I have done about damage detection for mammogram. So the basics, so here we have classification. So when we talk about classification, use a point here. Yeah. So general machine learning. So nowadays people are working with the deep learning. But once we have a data, so let us say we have some features are there and we have to do classification, then we have to go with the machine learning technique. And if you're directly using with images, then you can go with the deep learning. So here we have some input features are there. I mean, input data is there. There is, and we have to extract the features. In some data sets, if we go to UCA repository, we will have the feature extracted for various data sets, and the feature set as a table it is available in UCA repository. So you can use that. That is, we have the features and the class label. So here, what a traditional machine learning does here is we have the input data and we have to extract the features. So features are very important here for the traditional machine learning like ANN, SVM, or KNN and other classifiers. So we have to give it to a classifier. It can be ANN, SVM, KNN, and so many other classifiers. And we have to classify the output. So it can be, if we have two classes, it is called a binary. If we have more than two, it is called a multi-class, or that is the based on number of classes we can specify. It's a traditional machine learning approach for classification. And in classification, we have two important things that has to be considered. That is the training and testing. So if you talk about training, so here we have input, and we have to extract the features. Feature extractor will be used, and we extract the features, and we will give to the machine learning algorithm. That's the training. So training, it will have, let us say, usually they go with 70% training, 30% testing, or 60, 40, or 80-20. So these are the various options they'll go with. So more training, and the better the training, and we'll have sorry, yeah. So more training and less for testing. So these are the various ratios. They generally use it for training testing ratio. So once the model is trained, the machine learning algorithm, that is a classification algorithm, is trained with some, let us say 80-20, 80% of data we used to train here, and remaining 20% data will be tested here. So training testing ratio. The mostly the classifiers what we use, the accuracy predicted, it will be for the testing accuracy. So that will be the mostly we have to consider for the results and all those things. But in some papers, what the people will do the mistake is they will give all the data sets in the training and they will produce the training accuracy. That is not correct. So we have to have a training testing ratio, and in some places we have training, validation, and testing ratio. So validation is to uh, I mean, it has to optimize your classification. So it's a fine tune your classification. That is a validation set. So there is also other than training testing, we have also validation set also can be possible. So when we produce accuracy, so we have to use the testing accuracy for the results. So here, the main problem with these classification algorithms, traditional machine learning algorithms are, and the main problems are here if you're using ANN, SVM, decision tree, or KNN and all those things. The main problem is the amount of features and input data. So let us say we have more input data, it will have a better accuracy. I mean, better training. So if we have more data, we can train the classifier better. But what happens is if we have more number of features. So if we talk about the more number of features, so what happens is here, the features, if the more features are there, it will confuse your classifier or it will overfit your classifier. So we have to have a compact number of features that will give a best accuracy, but identify that. That is our objective in the traditional machine learning algorithm. So for reducing number of features, because if you have more features, it will overfit your classifier. So to avoid that, we have to get the reduced set of features. We have to identify which are the best features. And for that, we have traditional, I mean, we have various dimensional reduction methods. So that's what we're going to discuss today. So our focus is on the number of features used for traditional machine learning algorithm. So how to reduce the features? What are the various methods to reduce the features here? So dimensional reduction. So here, so the actually in theoretical point of view, they say that if we have more number of features, we have better performance. But that is not for the features. Actually, it is for the input data. If you have more input data, then it will have a better training, but not with the features. So if you have more number of features, it leads to worst performance or it will overfit the classifier or it will take, I mean, it will become very highly complex classification algorithm. So it will reduce that accuracy. So it leads to sometimes more features will reduce your accuracy. So so that is a main problem here. That is called as a curse of dimensionality. It means that including of more features will lead to worse performance. That is nothing but reduced accuracy. That is called as curse of dimensionality. So in place of, let us say we have 100 features are there, okay, in a data set for some any disease or something like that. We have extra some 100 features like texture features or some other features. So in this case, what happens is instead of using 100 features, we can select some select to 15 features or 20 features uh, out of this 100. That in case of using 100 features, let us say we get 81% accuracy. If you use 15 features, we may get an accuracy 83 or 84 percentage. So that may be a possibility of increase in accuracy. It may not be the case in all the cases. If we have only 10 features, if we're selecting 3 or 4 features, in that case, there may not be an increase in much difference in accuracy. But when we have a data set with 100 features, in that if you take the reduced set with 15 or 20 features, there is a possibility of increase in accuracy. So that is the main objective of this dimensional reduction, is to reduce the number of features. So here there is another concept, that is number of training samples required will increase exponentially with dimensionality. So that means that so we have input, let us say cancer images. So we have 100 images, 100 cancer images, 100 cancer and normal images. So let us say 50 cancer, 50 normal images. Okay. So totally we have 100 images. And for each image, we are extracting, let us say, 40 features. Actually, the number of features is very high. So in this case, number of images used here is only 100 images, but the number of features is 40. That means that this for uh, training the classifier to 40 features to identify which whether the features are good one to for classification and all those things. The number of images used here is not sufficient. For 40 features, we need at least 1,000 images for training your classifier. That is ANN or SPM or decision tree and any of these classifiers. If you have more features, we have more input data is required. So for each image, we expected 40 features. So if we want to, if the features are getting increased, then we also increase the training samples. So that is the meaning of the third point. The number of training samples or examples, you can take it as a training samples required increases exponentially with the dimensionality. Dimensionality here we are talking about features. So when we have high more number of features, more number of training samples is required. So that is not may not be the possible case in every place. So we need to reduce the dimensionality or number of features. So dimensionality reduction usually there are various methods are there. Nowadays we have optimization based methods, so many other methods are there. Uh, but generally it is classified into two types. One is feature selection and feature reduction or feature extraction. Feature reduction or feature reduction or feature extraction. Okay, so feature selection and feature extraction we can have it. So here what is our objective is for demonstration reduction method here is, let us say we have n features. So and we have to reduce it to k features. So k is less than n. Let us say we have 100 features here. We have to select only 15 features. So k will be less than n. So that is the objective of dimensionality reduction. We are trying to use the dimensionality. 11:31. Mr. And so here we have another method is there are two methods. One is feature selection, another one is combining features or feature extraction. Okay, so that is called as feature extraction. So combining existing features, linear or nonlinear transformation, that is called as feature extraction. That is one of the examples for this one is a PCA, principal component analysis. Okay, or ICA, independent component analysis.
Sir, Surendran sir. Sir, we are not able to hear your voice, sir. Sir, Surendran sir.
Yes, madam. There was a disconnection in the net. So
Yeah, okay, sir. Okay, sir.
power
Okay,
went
sir.
off.
Yeah,
Now
okay, sir.
connected through Wi-Fi. Is
Okay,
my
sir.
screen visible?
Yeah, yes, sir.
No.
It is visible, sir. You can continue, sir.
Wait a minute. Can you have one more? So I'll share it. Yeah. Yeah. So here we have two types. One is feature extraction and another one is feature selection. In feature selection, what we do is we have, let us say, feature set. Full feature set is there. So how many features are there here? 9 features are there. So from this, we are selecting only 3 features. These 3 features are getting selected. So final feature set will be 3. This is a feature Land power illiyamma. Madam, screen visible?
Yes, sir. It is visible, sir.
Okay, madam. Sorry, that is some disconnection with the Wi-Fi.
Sir, no problem, sir.
Okay. So where these demonstrated reduction methods are used as we have various numerical features. I mean, various attributes are exist for some data sets are available. So from that, we have to we have to apply for classification. All those things we can go with demonstrated reduction methods. And even for deep learning approaches, the main problem is with the number of features. So there, if you want to reduce the features, there is a next level they'll be working on with reducing the features. So there we can apply dimension reduction. And yeah, that is about where we can use it. And these are the various application areas. So generally with the handwritten recognition and all, so we have various pixels and all those things. So to identify different characters, we will go with the dimension reduction methods here for identifying each and every letters and all those things. Now these are other applications where it is used microdata analysis, protein classification, visualization, or any other data sets with the features we can use it. You can check UCA repository. So where we have various data sets are available for classification and clustering and all those things. So major techniques, as already I said, one is the feature selection approach, another is feature extraction or feature reduction approach. Now in feature selection, we have to select the optimal subset of features. That is, if we have 9 features, from the 9 we have to select the 3 features. So that is the feature selection approach. And the performance about this one is it is a learning speed of learning is very high, and it will be used for predicting the accuracy and simplicity and it's very simple to implement and all those things, the feature selection approach. The feature extraction approach, so we have to map the original high dimensional data into a lower dimensional space. That means that let us say we have n features, so we have to generate uh, some k or k features or lesser number of features. How they do in feature extraction approaches, let us say we have x1, x2, x and this many features are there, existing features. So what they do is the feature one will be like some weight 0, 1, sorry, weight, let me clear it. Weight 1, 1 into x1 minus weight 1, 2 into x2 minus or plus. It depends upon the how it calculates. It's eigenvalues and eigenvectors. If we take PCA and there are independent component analysis, factor analysis, so many other methods are image factoring method. So many other methods are there, and so W13 into X3. So like that, it will have some for first feature set. It will multiply with some weight values, or we call it as eigenvectors. And next one is it will have feature two. It will be like some other weight values, weight 2 1 into x1 plus 8w2 into some x2. So like that it will generate several set of features. So it will generate a fk features. Totally we have fk, this is fn. So if n number of features is reduced to k number of features. So here we'll have a linear or nonlinear combination of existing features. We'll generate a new set of features. So that is a feature extraction approach. Okay, so that is about the feature extraction. In case of feature selection, so from xn features we select, like let's say x1, x3, x5, like that. Only we select only any number of features. But in case of feature extraction, we combine with existing features and we generate a new set of features. That is, if one of the example is PCA, so we have PCA components are there. So PCA components are the extracted features. So in the feature extraction, all original features are used and we generate a linear combination of the original features. In case of feature selection, only subset of original features are selected. So if we go with the feature selection approach. So now this is for feature selection. Let me be in line just 2 minutes. Yeah. Yeah. So here for feature selection, the important thing is we have to, there are the various parameters you have to consider for feature selection approach. So here we have to identify what is the subset you have to search. So we may have 10 features. So what is the subset? It can be, we have several combinations. It can be two features you can compare, or any 3 features or any 4 features we can take. So what is the subset? How to identify the best subset? And we have to identify the subset that is called a subset search. And there is a feature ranking method. So we have to rank. So let us say we taken, there are several combinations of 4 features. So out of 10 features, x1 to x10, there are several combinations. Let us say we want to select only 4 features. It can be any combinations, 4 features. So in that one, we have to rank the features. Then you have to select the best 4. And to evaluate these things, we have some evaluation measures are there. So how to identify which 4 features will be best. So among these 10 features, which for any 4 combinations. So to how to identify that, so we have various evaluation measures are there. And to identify this best features out of 10, 10, that is going to select 4 features. So we have various models that is called the filter and wrapper based model. We'll discuss in detail. So filter models are independent algorithms without any classification algorithms. Wrapper is, it uses a classification algorithm. It wraps over classifier. So that is called as a wrapper method. So these are the basic 2 methods, filter and wrapper. In the filter method, we don't use any classification algorithm. It's independent algorithms to select the best set of features. Wrapper based method, it is wraps over a classifier. So classification, it uses a classifier. For identifying the best subset of features. So finally, we have to evaluate and we have to finally we have to select the 4 features from the 10 features. So we have to select the 4 features. So here, this is a subset problem. So in the feature selection approach, let us say from 10 features, we have to select 4 features. So in this example, the subset search problem, we have taken 4 features here. So A, B, C, D. So these are the 4 features we have considered here. So from these 4 features, we have to select the best subset. It can be 2 features or it can be 3 features. Or it can be all the 4 features may be the best subset. So we don't know which is the best subset. And is the screen visible?
Sir? Yes, sir.
Screen,
It is visible,
okay.
sir.
Okay, madam, okay. So from the 4 features, we have to select the best subset. So we here, how to we have to select the best subset is we have to check all the combinations and we have to identify which is the best one. So there are various methods. So let us say this is a search space for 4 features. So here we have empty set and finally we have the full set. All 4 features are selected. So 0 means that feature is not selected and 1 means that feature is selected. So here 4 features are A, B, C, D. Now we have to identify the best subset. So first we'll try with considering only A and we check only with B and we check only with the C and only check with D. So only one feature is selected. We can select any one of the one feature. It can be A or B or C or D. So now, so in this one, we don't know which one is the best one. So we have to select, let us say we found that B is giving a best result. So among individual features, one feature, B is better than A, C, D. Okay, so now next we have found the first feature. First feature we found is B. Next we have to check with the next feature, which is the next best one. So we can combine with A or C or D. So here we have AB. Here we have BC, and here we have BD. These are the four, I mean, sorry, these are the three combinations. So with the B, finally, first time we selected B. Now we have to check whether B with A is good, B with C is good, or B with D is good. So first is best feature we selected is B. Next best will be, let us say it can be BC. Let us say BC is giving a best one among A, B, BC, BD. So now second best feature is BC. BC is the next best feature, BC. Okay. Now next one we have two options. Either we can go with ABC or BCD. Let us say BCD is giving the best one. BCD. Okay, so next one is BCD, and finally we combine all the features. So we have ABCD. So all the four features are selected here. So the order of features selected here is first one is B, next one is C, then next one is D, then next one is A. So now this is the subset search problem. So here for four features, these are the number of uh, search space. Okay, totally search space is 2 power n. So that is, so here we have four features. So 2 power 4. So this many combinations are possible. So here we have 16 combinations. So for four features, we have 16 combinations. If we take, let us say we take 100 features, okay. So then what happens is 2 power 100, that is very large, huge amount of search space. So we cannot search each and every combinations and identify the best subset. So there are heuristic approaches that we have to consider. So this is the how yeah, feature selection approach will work. It will generate the search space, and it will identify which one is the best one among all these things. Okay. So here we can stop at either we can say that BC is alone is enough, or three features like BCD is also is can be enough instead of taking all the four features. Let us say we go with BC only two features. So from ABCD, we found that the best subset is BC. These two features is enough for classification. So remaining two is not, A and D is not important for classification. So this is how a feature selection approach will work. This is search space. So if we have 100 features, so 2 power 100, it will generate very huge amount of search space. We cannot search in all the combinations. So for that we have various methodologies for feature selection. So we can start with, there are starting points are there. So either you want to start it with the empty set, or you can start with a full set or from a random point. So what's mean by empty set, full set here is, so this is the empty set. So we start with empty set, or we can start with the full set. So if we take with empty set, we add one by one features. We'll add one by one, and if you take a full set, we remove features one by one, and we'll go to the top. Okay, so that is a empty set and a full set approach. So we can take either empty and we'll add one by one, or we can take the full set and we can remove one by one. So which is not important, that can be removed one by one. So like that it will go for from full set to till empty. Or we can start with any random point. Let us say we can start with here. We can add or remove from this point. So that is how random starting point will take considered here. And here we have various search directions. So here we have sequential forward selection, sequential backward elimination, bidirectional generation, random generation. So what is so here we have sequential forward selection. Sequential forward selection. So here we start with uh, empty set and we go forward selection. We'll add one by one. That is called as uh, uh, forward selection approach. And next one is backward elimination, sequential backward elimination. So that is we start with full set and we remove one by one features and we'll go in the backward direction. We eliminate the features one by one. That is called as backward elimination approach. So sequential forward selection is we start with the full empty set. We add one by one. That is a forward selection. If we start with full set and we remove one by one, that is called as the backward elimination approach. And we have bidirectional generation. So bidirectional generation says that if you are in this position, either you can remove one feature or you can add one feature. It can go in both directions. And next one is random generation. In the random generation, we not go with from this link. We can add in either point. So we can from here you can go to here. So it can go in any random direction. Okay, so that is random point, random generation method. Yeah. So the set strategies. Okay, so this is a starting point on how which starting point you have to take, either empty set or full set or random point. Search directions is so here we have forward selection, backward elimination, random generation, bidirectional generation. And here, what about the search space? So as already I said, if we have 100 features, the number of search spaces is 2 power 100. So it's very huge amount of search spaces there. We cannot search all the combinations to identify the best one. So there are various search strategies are there. So that is exhaustive complete searches. So if we take here, we do all the point search, all the combinations we'll check and we'll identify the best one. So that is exhaustive search or complete search. This may be good for small set of data. It may not hold good for a large amount of data. Okay, so that is the problem. I mean, the exhaustive search and heuristic search. Non-deterministic search techniques, it will be applied for binary generation and random generation methods. So here we will start with some random point and we can do go up and down or random that is random bidirectional generation. So these things they use for if the search space is very high, it will do the random generation approach. So that is for here we use a heuristic approach and non-deterministic approach. So here the search direction, sequential forward generation, sequential backward elimination or backward generation, bidirectional generation, random generation methods. And what are the search strategy? It is mapped here. And in the searching options, so when we start with, let us say, empty set, from the top empty set, we can go how to search for the next best feature. So we can go in a depth first search method, depth first, okay, or we can go breadth first search. So breadth, each and every level we'll check, then we'll check with the next level all the points here. So like that we can go with the depth first search. So sorry, breadth first search or depth first. So here, what we seen here, dimensionality reduction. Dimensional. Sorry, this. Okay, dimensionality reduction. So we have two types. That is feature selection, and we have feature extraction approach. Under feature selection, we have filter and wrapper based method. Under filter, we have and 130 and based methods. So now we have seen what is demonstrated detection, what is a feature selection approach, and what are the search strategies. Next, we'll see about what is a filter based approach, what is wrapper based approach, and what are the approaches for general and ranking based approaches. So demonstrated detection methods, we have feature selection, feature extraction. So feature extraction, we have PCA, ICA, and image factoring, and some other methods are there. In feature selection, we have filter and wrapper based method. So wrapper based method which uses a classifier. So filter based methods are independent method which doesn't use any classifier. So in filter based method, we have general method and ranking based method. So what is the difference between a general and ranking based method here is, let us say we have 10 features and we have to select the 4 features. Okay, from 10 features, we have to select the 4 features. So in general method, it will select from 10 features, it will select the best 4. It will select the best 4. But in ranking based method, it will not select the best 4. So it will give the rank. So which one is the all the 10 features it will show. It will show all the 10 features, but it will rank them in order. So which one is the best one, it will be given the first rank. So it will give for all the 10 features, it will give the rank. So from this rank, we have to identify whether 4 is good one or 3 is good one or 5 is good one. On trial and error basis, we have to identify. So we don't know whether for the 10 features, top 4 ranked features is best one or top 5 will be best one, that we don't know. So we have to use a trial and error method. We have to select the best top features. It is a ranking based method. In general methods, it will select the best subset. We need to wait for it to check and select it. It will give the best 4 features. It will give the list. In case of ranking, it will go only the ranking. It will not give you the. It will go only the rank. We don't know which subset is good one. Okay, so here we have ranking based method. What I said was it's under feature selection. So here we have to select the top ranked features for feature selection. So it is very easy to implement. And here, what is the problem here is to identify the threshold. Let us say we have 10 features are there. It will rank all the 10. It will rank them. So we don't know from this 10 ranks. So whether we have to go with only 3 or 4 or 5 or any which number of which subset we have to identify. That is called the threshold that we can't identify. So we have to use trial and error method. We have to identify the best subset. Okay, so that is a ranking based method. And here, when we go with the feature selection approaches, filter and wrapper based method. So initially we discuss about there will be evaluation measures. So let us say we have ABCD are 4 features. So we have to select the best 2, that is BC we have to select. So how to identify B is the best one or C is the best one? So we have various evaluation measures are there. These are the various evaluation measures. To what are these measures? Are these measures are used to identify which one is the best one? Sir, session wait. Huh? Session wait. சொல்லுங்க. Thank you. So here we have to identify the best subset of features. So for this, there are various evaluation measures. So various measures here are information measure, distance based measure, dependency based measure, consistency and accuracy. These are for feature ranking and feature selection algorithms. So here information measure. So we know about decision tree. Decision tree uses entropy and information gain. So those measures are used. These are called as information measures, which will be used to for these are called as information measures. And we have distance based measures. That is Euclidean distance, Manhattan distance. So these are all the various measures. And dependency measure, there is another type of measure. I'll talk about that. And consistency measure and accuracy measure. So accuracy measure is a measure. It will comes for wrapper based method, because wrapper based method which uses classifier. So for wrapper based method alone, we use accuracy measure. These are all used for filter methods. These measures are for filter. These are all. This is accuracy measure is comes only for wrapper based method. So we know about information measure, that is entropy information gain, distance measure like Euclidean distance and Manhattan distance. So consistency measure is let us say we have some data is there. Okay, so there are several features we extracted for some data. So if there are two instances. So if there is any inconsistency between two instances, that is what it will check. So I'll explain with an example. So this is a sunburn data. So the people have different hair color, height, weight, whether applied to the lotion for sunscreen lotion, and whether there is a sunburn or not. Sunburn 1 means there is a sunburn. 0 means there is no sunburn. Okay. So So 1 minute. So here, if you take I4 and I8, so here we have the person is having hair color is similar, height is also similar, and we have weight. There is a 2. Here it is 1. Not much difference. But the problem here is the lotion. So lotion, he has not applied the lotion. He had this person has applied the lotion, and you can see the result. There is a variation. So here there is a sunburn is here, but there is no sunburn. So if we take I4 and I8, the data first 3 attributes are same, and the lotion alone there is a variation. It leads to a result. So this is called as inconsistency. Uh, so that it will identify that as an inconsistency, it will check between the two instances. Two instances here are I4 and I5, I4 and I8 are called the instances. So here the inconsistency measures it will check for inconsistency or consistency between two instances to take a compare the features to identify the best subset of features. So that is what it does. So here accuracy measure. So this is it is used for wrapper based method. I already said accuracy will come only for wrapper based method because it wraps over a classifier. So classifier is evaluated using accuracy. So accuracy measure will come only for wrapper based method. So here we use a classifier, and the speed of building the classifier, it depends upon how fast it will execute this, depend upon the classifier we use, and it will try to improve the accuracy. But what's the problem with this wrapper-based method is it is biased towards the classifier being used. So let us say if in the wrapper-based method we use ANN, so this the feature selected, it will work only with ANN. It will not work with uh, other features. I mean, other classifiers. So the feature selected by using a ANN method, it may not work best with SVM or decision tree classifier. So that is what mentioned here. It is biased towards the classifier being used. And it takes more time consuming compared to filter based method. And so that's what we had discussed. So what we discussed till now was feature selection approach. So feature selection approach is it doesn't use a classifier. So it's independent feature selection separate algorithm or filter based model. And it relies on the various measures, information, distance, dependency, consistency measure. And it is not biased towards any learning algorithm because it doesn't use any classifier. And it is a very fast. And if you take a wrapper based method, so wrapper based method, it uses a classifier here. So it depends upon the classification algorithm, and it uses accuracy as a evaluation measure. It may produce a high accuracy, but it is highly computationally expensive compared to a filter based model. This is very fast. This is slower model. So it's how the filter model works. So we give the full set and we generate a subset of features. So we have to identify a subset of features. That subset is given for distance measure, that is evaluation measure, or distance or information or any other measure. So we measure whether the feature subset selected is a good one or not. If it is a good one, then will come out. If it is no, then again we select some another subset and we evaluate using a measure. And once we get the best subset here, so we got the best subset. So now we apply classifier here. So here we can apply with any classifier ANN, SVM or decision tree. Let us say here we have 100 features initial set, and after feature selection we got 15 features. So 15 features will be used for classification. So we apply to a classifier and we test the classifier, we get the accuracy. So this is a filter based model. The filter based model is in the top one. This is a filter based model. After the feature selection, we apply with the classification. That is the next part. The wrapper based model, it uses accuracy as an evaluation measure, and it uses a learning algorithm. Instead of distance measure, we use a classifier. So we use a classification algorithm. So classifier will be used here. So we'll give the full set. We identify the subset and we apply with some classification algorithm. So since we are using with classification algorithm, we use accuracy as the measure to validate the model. So whether it is a good one or not, if it is a good one, we select the best subset. Then we apply with the classification algorithm, training data, testing data, and we get the accuracy. So this is the two phases. Phase one is the wrapper based model, and we test. Then we do with the classification later. So before going into demonstration, so here we got iris power data set. So here we have in the Vika tool we have various data sets are there. So here we have iris power data set, and here there are three types of classes, and we have 4 features or variables for each and every images. And we have 150 instances or cases or samples are there. So what are the 3 classes here is, so we have iris versicolor, iris setosa, Iris virginica. These are the three types of flowers. So we have to classify whether they have taken some features. So based on the feature, we have to classify whether this image is Iris versicolor or Iris setosa or Iris virginica. So here we have four features. What are the four features are the sepal length and width, and internal pedal. This is the pedal length and width. So sepal length and width and pedal length and width, all the four features are used here. So using these four features, so because you can see there is a variation in the sepal length and pedal length and width for different setosa types, iris types. So using these four features, we have to classify them into three classes: iris versicolor, setosa, or iris virginica. So before going to demonstration, I will talk about another important feature. Uh, so here, generally we use for evaluation, what we use is accuracy, precision, recall, and other things. So recently, when we did research, we found that some new evaluation metric, or we call it as it can have a better comparison with the existing method. That's called as a cases to variable ratio. So let us take, we have a cancer image. Let's say brain tumor or some other cancer. So we have 10 patient cases, okay? And 0 means a normal, 1 is a cancer patient. Let us say for each and every image, they extracted some two features. This is for example. So two features are extracted. So using these two features, we have to classify them whether the first case is a normal or cancer. So here the number of cases instances is 10. The number of features here uses here 2, and cases to variable ratio. So CVB ratio here is cases is 10 and number of features we used here is 2. So 10 cases and we have 2 features. So 10 by 2 that gives you value 5. So why the CVB ratio is considered here is, so initially when we discuss about damage detection method, the complexity or the number of training samples required exponentially increases with the number of features. If you have more features, we need more training samples or more instances is required. So there is a no use of for 10 images. If you use 100 features for each and every image, let us say we are using 100 features for each and every image, it may not be optimal because it will morph to a classifier. We don't have a sufficient number of images or the cases. So here only 10 cases are there, but we may not have a more number of cases to validate this 100 features. We don't know whether we're not having sufficient samples are there to validate these 100 features. So if you have more 100 features, at least we need 10,000 cases. It's maybe required to validate this 100 features performance. So that's why the CBA ratio is very, very important, and it can be used as an evaluation metric when you're doing evaluations. So I'll show an example what we received. So we worked at the mammogram, that is a cancer images. So what we used is, this is the cancer tumor region. The mass is the cancer region. So tumor region. So it can be, the cancer can be different shapes: round, oval, regular, or irregular. And the margins or the boundary, it will be circumscribed, obscured, macrolobated, or speculated. So what we did was, we taken the tumor region and we extracted the shape characteristics, because we can differentiate The early stage of the cancer can be benign, and the advanced stage it have a different shapes. It will be malignant cancer. Benign is early stage, and it is advanced stage of cancer. So for this we used a shape-based metrics, geometric shape-based metrics, and we found that using shape-based metrics we can easily identify whether the tumor is benign or malignant. But most of the existing works, what they did was they focused on texture features. So this is where we used for 300 mammogram images. So our proposed work, we used 300 mammogram, that is breast cancer images. We extracted 17 features. So we used a shape-based measures. We used only 17 features. And if you see the CVB ratio, what we got is 17.64. So 300 by 70, it will give you 17.64. 300 images, 300 mammogram images. For each image, we extracted 17 features. So we got CVB ratio 17.64. If you see the literature works that time, so it was like 322 images, mammogram images they are taken. For each and every image, they use 300 wavelet coefficients. So for each and every image, they use 300 coefficients. That may not be effective one. Afternoon. So here the CP ratio is 1.07. And if you take 144 images, another work, they used 280 structure features. So which is very, very large. It is more than the number of sample images. So in this case also, the CVB ratio is 0.51 only. So the what is optimal CVB ratio we have to have? The optimal CVB ratio should be greater than 4.16. It is a mathematically proven value. So CVP ratio should be greater than 4.16, then it is the best feature set. So you can, other than the accuracy and other measures, we can use CVP ratio as one of the evaluation measure. Okay, let me, so what are the features we used? I'll show you that. So here what we consider is we used shape-based measures. So benign tumor will have a rounded oval shape. Advanced stage of cancer it will have a globular and irregular shapes. So most of the research works they not consider irregular and globular based images because these are difficult to classify. So these are the features we used for our research. So what happened? What we considered is we created a new set of features. We modified existing algo feature set. We created a circularity, modified circularity. Like these are the new features we introduced, which is not there in the literature. Actually, let us say if you take a shape index, the actual this one is perimeter by 2 into radius, 2 into r. But instead of taking radius, that is a average mean radius. So what we used is instead of that we used a max radius. So like this we changed the parameters, all the equations here also instead of a radius we used the max radius. So like this we defined our new set of features which are found to be effective in discriminating the shapes. Because shape-based features, we have to differentiate the various shapes, round, oval, regular and irregular shapes. So this is the contribution we did. So for this, we have taken basic shapes and we extracted various features for that. And we modified the features and we found that some features are effective in discriminating the various shapes. Another day of these shape-based measures are it is push invariant, rotation invariant. Either the tumor is here or tumor is here or in another place, it will give the same set of values. Whether the tumor is in this position or in this position, so it will give the same set of values. So that is advantage of shape-based features. So now let us, I will go to the demonstration using Vika tool for Hayes flower dataset. So Iris flower dataset, one minute, I'll check slide number. Yeah. So iris level data set, we're going to see demonstration using Vika tool. So here we have three types of classes: iris versicolor, iris setosa, iris virginica. And for each image, we have uh, four features: sepal length, sepal width, petal length, and petal width. So let us see the demonstration. I'll stop my presentation. Uh, and let me share my screen, entire screen. Okay. This is a Vika tool. So here we can use only with CSV files. We cannot use Excel files directly. Then what you can do is you can use a ARF viewer. So it also uses a own format like ARFF format. So if you want, you can use ARF viewer and you can open your files, a CSV file, you can convert it into ARF format, or in the Excel file. If we have data in Excel file, you can save it as a CSV, then you can import here. So here it has various interfaces to work with. So Explorer, Experimental, Knowledge Flow, Workbench, Simple Command and Interface. You can go with Explorer. So here we have several steps are there. So pre-process, classify, cluster, associate, select attributes, and visualize. So we'll be seeing with select attributes contains filter and wrapper based methods and feature extraction based methods. And classify, we have to use the classification. It's very simple to use. We can do no need of any programming language. So let us try with. Okay, Vika 3.8.4. So this is the version I'm using. 3.9 also there, but we have to install all the packages one by one. Whenever you need it, only you can install. So 3.8, it comes with some inbuilt packages. So here we have where the datasets are there in Vika folder data. So here it gives this many datasets. It comes along with Vika tool for different association rule mining, clustering, classification, and various methods. They have given the various uh, datasets are there. So we're going to use iris dataset now. So I'm going to open iris.arff. So here we have four features: sepal length, sepal width, pedal width, and we have class labelers. We have three classes. So what are the three classes here? So three classes here are iris setosa, iris versicolor, iris virginica, each containing 50 instances. Totally 150 instances are there. And for each 50 images, they extracted four features: sepal length, sepal width, petal length, and pedal width. Under total 150 images, they extracted four features. Okay, totally 150 instances are there. So now we have to do feature selection. So first we have to check without feature selection, what is the accuracy. Let us go to classification. So here we have to choose the classification algorithm. So let us choose. You can go to functions. We have multi-layer perceptron. That is a multi-layer neural network. And we have navy bias. Let us choose navy bias. So here you can go with the 10-fold validation or 5-fold validation, or you can use percentage split. So percentage split, you can give it like 70-30. That means it will take 70% for training or 80% for training, remaining 20% for testing. So now, so let us go with 80-20. That is 80% for training, 20% for testing. The classifier we chosen here is navy bias. So if you want to so if you want to change the parameter for this classification, you can click on here on the navy bias name. It will open a window where you can change the parameters. If you want to know what are these parameters are, click on more. So it will show you what is algorithm and what are the various parameters, what are each on each and every options, what is these options. So you can learn about that. So we will not change the parameters, we use existing parameters and we have to go with classification. So we are here, what we are choosing is we choose a navy bias classifier, 80-20 split ratio, 80% for training, 20% for testing. And here we have to choose the class label. Actually, class label will be the last parameter. Sometimes it may not be in the last parameter, then you have to choose the class label accordingly. Then click on start. So now we got an accuracy here. So here it uses navy bias classification. Iris dataset, total 150 instances are there, totally 5 attributes, sepal length, sepal width, pedal width, and class label. Split ratio is 80, training, remaining testing. So finally we get an accuracy. It is a correct classified instances. That is, it has taken 30, 80, 20% for testing. Totally 30 instances are there. So amount 29 are correctly classified. That is 96.99% accurate, 96.66% accuracy. And we have one misclassification. And here we have confusion matrix. So we have three classes. ABC. ABC is Aris Setosa, versicolor and virginica. And so this shows the confusion matrix. So now we have to apply feature selection approach and we have to check the classification algorithm again. So here we have gone to the tab select features. So here we have various methods. So we have a filter, wrapper based method and feature extraction approach. And in filter based method, we have normal methods, general methods and ranking based methods. So here the wrapper based method, we have wrapper subset evaluation, the last one, the wrapper subset, and we have classifier based subset evaluation, classifier attribute evaluation. These are a wrapper based method. And general method is CFS subset, gain ratio and all general methods. And relief F is the rank based method. Okay, so and we have principal components is feature extraction approach, principal components. So let us go with CFS subset. It is a filter based method. So let us choose CFS subset, and when you choose a CFS subset, you can give the parameters. So I'm not changing any parameters now. And here it has to use a search method, whether which search method it can use. So it will chooses automatically the best search method for this evaluation method. So for CFS subset, best first search method is the default chosen that. So now we have to specify whether the dataset contains a class label or not, because it has to without a class label, it has to identify the best feature. So if a class label is there, we have to specify that. Now we have chosen CFS subset evaluation, best first search method, and let us click on start. Now it is a filter based method. It will give the best features. We have 4 features. It will give the best feature, which is the best one. Let's click start. So here you can see it given the best feature is 2 features, pedal length and pedal width. So among the 4 features, the selected feature is pedal length and pedal width. So only these 2 features are enough. Okay, that is we need not to use sepal length and sepal width. Only pedal length and pedal width is enough. So that's just CFS subset. So now let us check with wrapper based method. So in the wrapper based method, so we are choosing wrapper based method. Wrapper based is the classifier based. So here it uses 0R as a classification algorithm. So I have to change that. I click here. Let me change it to J48. Sorry. J48 is a J48 is C 4.5 algorithm, which is a decision tree algorithm. So now let us we have chosen this classifier as J48. Click OK. So now we are chosen wrapper based method with the classifier as J48, and we have chosen the search method as best first. Let us click on start. Let us see whether the wrapper based method is which feature it is giving. So this feature method, it chooses only pedal width as a best feature, void of any other features. Even from the 4, it has chosen only one. That is a wrapper based method. But what is the problem with wrapper based method is this feature set selected will be works best with the decision tree. It will not work with SVM or other classifiers. Now let us choose another method, that is let us choose relief of attribute, that is a ranker based method. So now it shows that ranker search algorithm relief of attribute uses the ranker search. So we have to click yes. So now relief of attribute is a method and it uses a ranker as a search method instead of best first or depth first search and other things. It uses a ranker search method. So now ranker based method, what it does is it rank all the features. It will not give the best subset. So here in our data set, we have 4 features: supple length, supple width, pedal length, and pedal width. Maybe the first CFS subset evaluation method given pedal length and pedal width as a best feature. The wrapper based method J48 given pedal width alone is the best feature. So now ranker based method, it will not select the best 4. I mean, among this one best one, it will give the rank of all these features, all the 4 features. So now go to select attributes. Now I choose a relief of ranker based method, ranker based search. Let us click start. Okay, so now it says that ranked attributes. The ranked attributes are among the for all the 4 features will be ranked. It says that pedal width is a top ranked one, 4th feature. Pedal length is a 3rd feature, which is second rank, top second rank. Supple length is a 3rd rank. Pedal supple width is 4th ranked feature. The order of ranking is 4th feature, 3rd feature, 1st and 2nd. So these are the ranking of all the 4 features. So now from the ranking based feature, we can select only top 2 or top 3 or top 1. So that we have to identify based on Thailand method, we have to identify the best top features. So now let us go with the CFS subset. So CFS subset has selected pedal width and pedal width, pedal length and pedal width. So now let us do classification with only these 2 features. Previously we did Navy bias classification. So here we did Navy bias with all the 4 features. We got 96.66%. Now let us do with only 2 features. So we go to pre-process. So we have to select only pedal length and pedal width. So supple and supple width, we'll remove it. Click remove. So now we have only pedal length, pedal width, and class label is there. So again we go to classification and we do Navy bias and we are choosing the class. So click start. Yeah. So now with the 2 features, again we got 96.66%. So here we have only 2 features are there. So pedal length, pedal width, and class label. Only 3 features are there. So supple and supple width we have already removed. So again with the 2 features we got 96.66%. So there is no change in accuracy because this is a small data set. But if we take a big data set, there may be an increase in accuracy. But what we identified here is from the 4 features, we need only 2 features are enough. Okay, that's all from my side. I'll stop my presentation.
Yes,
Any
sir.
queries? Any
The
queries?
Dear participants, you can ask your queries by raising your hand. We will give access. Yeah, Ramya madam.
Ramya madam, you can talk, madam.
So thank you. Am I audible?
Yes, madam.
So good afternoon, sir. Thank you for the wonderful informative session. I have a small question regarding the paper that you have showed. That is identifying the mammography, that is whether it's tumor or not. You told that you have identified additional features. Have you
Yeah,
worked
yes,
with
madam.
the labeled data, sir? It is about labeled data. Am I right, sir?
Yeah.
Uh, can you tell me what is the objective that you have done in that paper? Because I am currently working on what is that MRI reports, scan reports, images. So before that,
Okay.
I have a plan of working with the labeled data to have a practice of how to do. Can you tell
Okay.
me what was the workflow of the paper that you have done?
Yeah,
The objective of how?
most of the works they worked with only texture features. So if you take a BIRAD, that is called as a BIRAD standard, BIRADS standard, that you can check for cancer images. It specifies that the tumor can be classified only based on the shapes and margin characteristics. So only the shapes can be used to differentiate the benign and malignant tumor images. So what we did was we focused on shape-based feature and we introduced some new features for that. And also we applied demonstrated direction method. So we extracted only 17 features. So these 17 features are very effective in classification. And later we reduced the features from 17 to I think 7 or 8 only features only to be used. Instead of like texture feature value coefficients I showed, they used 300 or 200 features. So we used only with 8 features, we are able to classify the images effectively. And
Okay.
what we used is we considered a, BIRAT standard or breast imaging standard. That is the standard they use it to classify the tumors. You can check that.
Okay, sir. Okay. So which are the machine learning algorithms you tried for getting the better performance, sir?
Uh, Actually, I have used various tools, madam, like Vika, PSW modeler, SPSS, and all those things. The classification algorithm, we
Okay.
initially we went with the discriminant analysis classification, and later we used ANN. These are the decision tree classification. And since it is a future based, we can go with the decision tree. Decision tree will give you a better interpretation of your results because we know which features are impacting on your result. If you go with ANN, we may get a result, but we don't know which feature is giving the importance for your classification.
Okay.
So we don't know which classifier will be working best because it depends upon the data set and features.
Okay.
So you have to check with most of the methods. You can go with SVM, decision tree, and ANN.
Okay, sir. Okay. Sir, another doubt, sir.
Yeah.
So when you're planning to work with the images,
Mm.
particularly on the biomedical images, and selecting the CNN as the architecture component to work on to train the
Okay.
model,
Yeah.
do we need to pre-process the images for getting the better performance, or the CNN can extract the features automatically with a better performance, sir?
Actually, CNN it will extract various features, madam. Whether you pre-process or not, you can it will give the more or less similar results only. But one thing you can focus there is instead of giving the full image for training, you can give the region of interest for training that may give a difference in accuracy in CNN.
Okay.
But
Sir,
in future, I mean, contrast enhancement or pre-processing will not have.
okay.
Hello.
Sir.
Yeah. So if you go with instead of pre-processing, you can go with region of interest based. So that will give you a better, maybe better performance you make it.
Okay, so for extracting the region of interest, we need to, are there any approaches available, sir, or we need to write codes or something?
No, you can, it depends upon the data set you are going to use. Some data set they provide
Okay.
with the region of interest locations, and the area also they will provide with along with the data set. So that you can use it to extract the region of interest.
Okay. If it
Or
is
you have
not
to,
there, sir, if
there
it is
means
not there.
you have to do pre-processing and you have to extract, or you can do manual extraction also. That can be also used to train your data.
Okay, sir, thank you so much.
Okay.
Is any other queries from participant side? Okay, thank you, participants. On behalf of Department of Computer Applications from MITS, I express my heartfelt thanks to our resource person, Dr. B. Surendran, Associate Professor from NIT Karaikal, for sharing the informative session. It enlightened our knowledge on dimensionality reduction methods. Thank you for your valuable information, sir.
Yeah, thank
Once
you.
again, thank you.
Okay, I'm leaving the meeting.
Then, yes, sir. Thank you, sir. And I thank all the participants who have